There it is.
Okay, so let's try to do related rates. What's related rates? It's a question where you're given relationship between two variables, and if you're given the rate of one variable, you have to find the rate of the other one using the relation between them. That's what related rates is, okay? Usually when you have a related rate question, you have this word when, or sometimes as, or something similar. That is something that you should pay attention to, and you'll see why a little later. Okay. All right. So, solution. Now, quickly we will be moving on to word problems, and word problems are harder because of the relationship between the variables is something that you have to figure out. Actually, assigning variables will be even harder. You have to know which variables to assign letters to, and then find the relationship between them, and only after that you can solve. Okay? But here, this is an easy question because the relationship is already given to you, and therefore you can use this to find the other ones. Okay. Now, what you need to know is that when you see this dx dt, this means how fast x is changing with respect to t. It's a rate of change of x, and this is the rate of change of y. You also learned that derivatives has the meaning of the slope of the tangent line. Actually, it has two meanings. Okay, so this is the rate of change of x, rate of change of y, and that means that x is a function of t and y is a function of t, because when you're writing this, you're considering y as something that changes when you change t. Is that right? So x and y are both functions of t, and that's why you have to think about when you differentiate this. See, in order to find the relationship between the derivatives, you have to differentiate this, and when you differentiate it, you have to remember that these functions are both functions of t. So let's differentiate it, where you should be always aware that derivatives here in this context mean differentiation with respect to t. Okay, so here I have a function of t, I have another function of t multiplied together. What do I use?
Product rule.
Product rule. So I have x prime y plus x y prime. What's the derivative of 4?
0.
0. Okay. Now, question. What's x prime?
dx dt.
dx dt. It's not 1. It's dx dt. Well, it's 10. But I just want to point this out. That this prime is its differentiation with respect to t. And therefore, this is dx dt y plus x times dy dt equal to 0. So that's the relationship between the derivatives and the function. And now let's go to the question and see what the question is asking. So it's asking for dy dt, and here's a very important symbol that I want you to use, so I'm going to use a different color. This straight line down, okay? That's the symbol for when. And then, what does it say? dy dt when x equals to 3. So you write down x equals to 3 after. Now, what's the significance of this? Well, the significance of this when is that you're supposed to plug in this value of x equals to 3, not in the beginning. You're not allowed to plug it in here. That's not allowed. You do this after you differentiate. To find dy dt, you're going to find dy dt after you plug in, after you differentiate, and then you can plug it through. So let's do that. Now, in order to get that, since dx dt is 10, x is dy dt,
3.
x is 3. Now I can plug it in because it's differentiated. And then dy dt is what we need to know. Okay, but this is not good because you still have a y that you have to determine. Okay. So in that case,
4 over x.
you say when x equals to 3, what's y? You have to think about the y value. Then you plug it in here. Okay. When x is 3, 3y equals to 4. So y is 4 over 3. Right? So you plug that in here. Okay, so let me state this clear. This when means you can only plug it into this one after you've differentiated. Do not plug in the things that you have here before you differentiate, because if you plug it in and then you differentiate, then these will be numbers and you'll be totally confused what to do with them. Okay? So, but once you have differentiated, then you don't have to worry about plugging into any of these. Okay? You can plug it in. Okay, now let's solve for dy dt. This is 3 dy dt equals to, that's 40 over 3, so it's negative 40 over 3. And finally, if you divide by 3, you get dy dt equals to negative 40 over 9. And these questions kind of show you the basic structure of a related rates question. Okay? The related rates question usually have this type of question. It's good to look at the last sentence first. It's asking for dy dt when x is 1. So in a related rate question, usually it's going to be asking rate of change of one thing when given some condition. Okay? And again, I want to stress that this thing should not be plugged in before you differentiate. Only after you calculate the derivative, you're free to plug these in. Okay? And another thing is, because you're given the rate of one variable and you're asking for the rate of another, there must be a relationship between the two variables, which we are given here. And then you find the relationship between the derivatives by taking the relationship and differentiating. Okay, I should have first explained what this question is. So this question is about a graph. It's a parabola that looks like that. And you have some point particle moving on this path. And it says dx dt is 2. That means the x directional velocity is 2. So you have a particle that's moving like that, where the horizontal distance is kept as constant. Okay? I mean, that often happens in physics. So for example, if I throw a ball, it draws a parabola, but the horizontal distance is always constant, right? So something like that could work. Yeah. And the question is, what is the y-directional speed? The y-directional speed changes, but the question is, what's the y-directional speed right here? That's the question that we're trying to solve. But you don't even have to draw this graph to solve this, because if you know the structure of a related rates question, all it's asking you to do is find a relationship, differentiate to find the relationship between the derivatives, and then you plug in this when. That's it. Let's do it. Y equals to x squared minus 3x differentiate. Okay, so what do you get? Y prime should be written as? Y prime is y prime, but in this context it should be dy dt. X and y are both functions of t. Yeah. Okay, x squared differentiates to?
2x dx dt.
2x dx dt. Thank you. See, x is a function of t, which is nested inside the square function, so you have to pull it outside and differentiate by t. and minus 3, and you have x prime, but what is x prime?
TXT.
TXT. All right, and then you're asking what is dy dt when x is equal to 1. So you plug in 1 into x, and then dx dt is 2 minus 3 times 2. So that's 4 minus 6, which is negative 2. So we see that it's going downwards at the speed of negative 2. Very simple, right?
Yeah.